7, part 2. We're going to be multiplying and dividing rational expressions. So not super hard, actually quite easy, but we had to be really, really good at factoring to be able to do this. So we spent a few days on that. So remember that when adding and subtracting a fraction, you have to get a common denominator. But when multiplying rationals or when multiplying fractions, you do not have to get a common denominator. You simply multiply straight across. So in something like this, guys, we can multiply straight across. Now we could do this a couple different ways. Technically, we could simplify right here first and then multiply straight across. Now that's what we do with a rational expression. So that's what I'm going to do instead. So does everybody see how we have a 3 on top, a 3 on bottom? So we have 3 over 3, so those divide out and become a 1. Is everybody following me? So I'm going to do it this way just so that this is how we would simplify a rational expression. Then 4 and 2, they both divide by 2. This becomes 1, this becomes a 2. So then from here, now that we've divided out all common factors, we multiply straight across. 1 times 2 is just a 2 on top, and on bottom 1 times 1 is just a 1 on bottom. 2 over 1 is just 2. So that's the same idea as simplifying rational expressions, exact same thing. So now we're going to do that with rational expressions. Now here's the important part. You need to factor every piece first, and then you can start dividing out exact factors. Let's not make any weird errors like we were a couple days ago and we weren't quite there. So if it's being multiplied, you can simplify it. If it's adding or subtracting to something, they're connected. So look at this. Number 1 on the worksheet, 4-7, day 2. We have 5n squared over 3n squared times 3 over n. We don't need a common denominator. We simply are going to factor this and then divide out common factors. This is already factored, right, everybody? If we really needed to, though, we could write it like this. 5n times n, because n squared is n times n. 3n squared, that's n times n. And then times 3 over n. So then from there, we'll divide out exact factors. So now we'll simplify it. N over n becomes 1. N over n becomes 1. We have 3 over 3. That becomes 1 over 1. So then all that's left is 5. Now we've simplified everything. Multiply straight across. 5 times 1 is simply 5 on top. 1 times n on bottom is simply n. 5 over n. So this simplified. Now notice if you read the directions, it doesn't say anything about restricting the domain or anything, so we're just simplifying. Is everybody good with that? We're multiplying and that's it. Okay, that was pretty easy?
Yeah.
Okay, let's do another one, and then I'll let you work. Number 5, n squared minus n minus 20 over n squared minus 4n times by 2n squared over n squared minus 25. The first thing we're going to do is factor each piece. So I'm going to focus right here. I'm going to go over here, give myself some room. So we're doing what multiplies to be a times c, what multiplies to be negative 20 because it's quadratic, right? And adds up to be negative 1. 5 times 4, right? And the negative would be with the 5. Once again, negative 5 plus 4. So our factors are negative 5 and positive 4.
Oh, no, I see.
Yeah, good questions. Yeah, so you were asking where the negatives came from, and now you're seeing them, so good. Also, can we quick factor this one? Yes, because our a value is 1. So that top piece, and I'm going to rewrite it over here. Let me give myself some room. So this piece became factored to be n minus 5 times n plus 5. n plus 4. Right, everybody? Any questions? No questions? Okay. Now let's factor this piece. Now don't say, I don't know how to factor that. You do. Remember the first thing was factoring. That's why we practiced the GCS thing the other day. Factor out what's in common from the beginning. So I'm just going right here to give myself some room. What's in common in 4n squared minus 4n? Good. We'll plot an n. So then left is n minus 4. So now that piece factored to be n minus 4. n minus 4 times n. Okay. Does everybody see how that's just those two pieces? Continuing, I'm going to change colors again so we can stay focused. That piece stays the same. So we have times 2n squared. I'm going to write it as 2 times n times n. Because n squared is n times n, right? Okay. And then I'm going to factor this piece m squared minus 25. So once again, it's quadratic, nothing in common. I'm going to factor it right here. So we do a multiplies to be a times c, 1 times negative 25, and adds up to be b. b is 0 in this one. So 5 times 5, one of them must be negative. Well, positive 5 minus 5. So our factors are negative 5 and positive 5. Is everybody comfortable with y? Kind of went fast, but I'm hoping at this we're getting to the factoring pretty quick here. So we can quick factor since our a value is 1. So this factors to be m minus 5 times m plus 5. So we've simply factored each piece. It's literally the exact same thing. This is the factored form, non-factored form. And now we can divide out exact factors. So now we can start dividing things out. Any questions before I divide it out? Okay, we have an n minus 5 on top. Do we have one on bottom? Those became 1. We have an n plus 4 on bottom and an n plus 4 on bottom. Top on bottom? No, right? That's going to stay put. N plus 4, nothing to divide with that. We have a 2 on top. Anything with 2 on bottom? Nope. M on top, do we have an M on bottom? So that M's gone, becomes a 1. Alright, M on top, nothing on bottom more that can divide out, right? So now looking what's left, 1 times M plus 4, so we have an M plus 4 in parentheses. We have a 2 and an M left on top. Now it's prettier to write that in front, so I'm going to write that in front. Does everybody understand how that's what's left on top? On bottom, I have an M minus 4 times some 1s, and then times M plus 5. So I have M minus 4 in parentheses times M plus 5. And then once again, from there, we're done. That is our answer here. Is everybody good with that? Not too bad, as long as you can factor, right? And we don't make any weird errors like saying, oh, well, there's an M right there and an M right there, so those divide out. No, because M was connected to negative 4. But I think we're past that point since we spent that extra day. Okay, so now, number 10, last thing is I'm going to just let you work. It asks us to find the reciprocal. Reciprocal is literally taking that exact thing and flipping it. So technically, isn't this the fraction x squared minus 2x minus 15 technically all divided by 1? So isn't the reciprocal just taking that and flipping it? So it's simply 1 over x squared minus 2x minus 15. Now, if that answer isn't a choice, and it's in linear factors, we know how to factor that. We would say, oh, it's quadratic. What multiplies to be negative 15 and adds up to be negative 2, 5 and 3, negative 5 and 3. And it factors, quick factors. So this bottom piece factors to become x minus 5 times x plus 3. So the reciprocal was 1 over x minus 5 times x plus 3. Is everybody good with the reciprocal? So what's the reciprocal of 2 over x? X over 2. It's seriously that easy, okay? So reciprocal, the reason we're talking about reciprocal for a minute is it's going to come up in division. So anyways, do the front page. Ready, set, go.
Yeah.
Haven't you ever heard the saying? Haven't you ever heard the saying? Ready? Dividing fractions is easy as pie. You flip the second fraction and multiply. So I'm going to say it again. Dividing fractions is easy as pie. You flip the second fraction and you multiply. So everybody look up here. 2/3 divided by 4/3. Well, that's easy as pie. We flip the second fraction and we multiply. So we're going to have 2/3 times, you got to flip the second fraction. So 3 over 4, and then you're multiplying. So then it's easy. We already know how to do this. Then you'll divide out common factors. That becomes a 1, a 2, that becomes a 1, a 1. So we get 1/2, right? Because we know how to multiply fractions. So we're not learning anything new.
No.
So I'm going to do problem number 12.
12.
6x minus...
Easy one. Don't do that one.
Nah, I'm good. I'm going to do it. Okay. Because you can do the hard ones.
Number 15.
No request, sorry, sir.
Okay, sir.
6f minus 6 divided by 3f minus 8. And we're dividing 6f minus 6 over f minus plus 9. Dividing fractions is easy as pie. Flip the second fraction and multiply. So we're really doing 6f minus 6 divided by 3f minus 8 times, flip the second one. So f plus 9 goes on top, divided by 6f minus 6, right?
Sure.
Do you get it? Sure. Yes or no? Sure means no to me.
Yeah.
Okay.
Yes.
All right. So everybody, then we factor it. I'm going to pull a 6 out. So left is f minus 2, right? Minus 1. I could, but I'm just getting in the habit of factoring things. Could just divide them out.
Yeah, okay.
But I'm just getting in the habit. 6f minus 1. Factor out a 6f minus 1, right? So then look, exact factors. Nothing else factors, so those divide out, right? It could divide out in the first place. I'm just getting in the habit of factoring. So then left, so yes, those divided out. So left was an f plus 9 on top, then we just multiply straight across, and on bottom we have 3f minus 8. Question. Okay.
Nope.
Dividing fractions is easy as pie. Flip the second fraction and multiply. Do 12 through 15.
Go back one.
Good, so let's talk about it. I'm seeing a couple people actually in this class thinking you can just divide these pieces together. So they're doing 27 over 3 is 9x, and then negative 5 divided by negative 5 is positive 1. But we can't do that. Does that make sense? So I like that error because we needed to talk about it, and I've never talked about it. So I'm glad I got to see that. So make sure you don't do that. Okay, everybody? You can't just divide up pieces. Does that make sense? Okay. Okay, complex fractions, guys. If you see the word complex fractions, it just means a fraction being divided by a fraction being divided by a fraction. So we have a fraction right here. We have a fraction within dividing more fractions. Do you see what I'm saying here? Now this looks a little bit harder than it really is. What we have to do is just focus on this piece, and then focus on this piece and simplify it. So we're going to rewrite this as one fraction. So we're going to have to add these up, right? To be able to add, we have to get a common denominator. So I'm just going to focus on this piece for a minute. Well, to get a common denominator, I'm going to multiply the bottom and the top by 2, right? Because that's like 1. So then I would have x over 2 plus 3 times 2 is 6 over 2. Now I have a common denominator. So now I can rewrite that as one fraction, x plus 6 over 2, right? So do you see how I just simplified the top? Now it's just one fraction. Now on bottom I'm going to do the same thing. This is like having a 1 over 1. So I'm going to get a common denominator, multiply the bottom and top by 5. So I have x, So I have x over 5 right here, minus 5 over 5. Now we have a common denominator, so we can rewrite it as one fraction. X minus 5 over 5. So what this really was, we simplified it, so really all we were doing is this divided by this, right?
So what made you choose a 2 and 5?
Because how do we get a common denominator? Between 1 and 2, what's the common denominator? 2. So we manipulate it, right? Getting a common denominator. So I'm going to multiply the bottom and the top by 2. We learned this 2 days ago.
But if there's a letter instead of a number, you just...
The same thing, we did this 2 days ago, right? If it was an x, 2x, we would multiply by 2x, right? Do I need to go slap somebody's face out there?
Yes. Don't yell out some weirdness.
Come on. Here we go. So, dividing fractions is easy as pie. You flip the second fraction and multiply. So now I'm going to flip the second fraction, 5 over x minus 5. And then we multiply straight across, nothing divides out, right? So we have 5 times x plus 6 over 2 times x minus 5. And we're done. Do you get how to do it though? Simplify the top, simplify the bottom, then dividing fractions is easy as pie, flip the second and multiply. Okay. Do 16 and 17 as well as you'll just finish the worksheet. You're going to need the formula for volume on number 18, which is length times width times height. And for number 19, here's the formula for distance. Distance is equal to rate times time. Plug things in, solve for what you need to solve for. Simplify. Finish the worksheet. Finish the worksheet.